everyone once again for the G on the Beach conference. I am a little bit nervous, but I'm also excited to be presenting in front of all you all. So I'm Rashmi Nagpal, a software engineer by profession and a researcher by passion, working mainly in machine learning. And today I'm super excited to welcome you all and looking forward to sharing my learnings on the topic Unearth the Black Box, Building Fair, Accountable, and Trustworthy ML Systems. So without any further ado, let's begin. So the agenda of the talk is, firstly, we'll discuss what is machine learning and its related concepts to bring all of us on the same page. Then we'll understand what is the core black box problem and why sometimes machine learning gives biased and unfair decisions. Further, we'll explore some strategies to build fair, trustworthy models and factoring in the accountability. And towards the end, I will highlight key takeaways from my talk and a bunch of resources for your future reference. So let's understand the broader meaning of machine learning and its related domain. So AI is a very broad term, and machine learning is a subset of the AI, which focuses on development of the algorithms that learns from the data set and its corresponding features, and it gives you the data-driven decisions. While the deep learning, it's a subset of the machine learning, which extracts the pattern from the data set and gives you the data-driven decisions. For instance, the handwriting recognition is an example of the deep learning, and spam email detection is an example of machine learning. Okay, now, so I've explained the basics clearly, and I want you to take a minute, and I just want to test the waters. I want you to take a minute and think which of these faces are real. Now, please raise your hand if you think that's the face A, which is the real one. Okay, awesome. Now, please raise your hand if you think that face B, which is the real one. Interesting. Okay. Now, please raise your hand if you think face C, which is the real one. There you go. Okay. Well, the answer is none of these faces are real. So this is an application of the deep generative modeling. So what happens in the deep generative modeling is that the algorithms are not only learning the patterns from the data set, but also going a step beyond in synthesizing the brand new data instances based on those learned patterns. So this is a very complex and a powerful, incredible idea, actually, I would say, which has exploded in the recent past. For instance, the ChatGPT, if you're aware, which is so much hype which is going on as well. DALL-E, these are some of the examples of the generative AI. But wait a minute, what's the building blocks behind all these algorithms? So that's where neural networks comes into the picture. So in the neural networks, you are given a data set as an input, and that's a very basic example over here. And consider machine learning at the moment as a black box, which comprises about the weights, sum and bias, and activation function. And then it gives you the output. Output could be any use case that you're trying to solve, right? So let's understand this basic neural network structure through an example. Okay, here our use case is that you need to determine to which animal category this image belongs to. So you're given an image, right? So you're feeding the image data set as an input, and the system will understand it as nothing but as a combination of zeros and ones, and then it will give you some prediction with certain accuracy. So after applying some image recognition algorithms, it will give you, oh, this image belongs to the cat category with 82% confidence or an accuracy. But wait, if you want to deploy this image recognition model, then, for our end users, then what is the machine learning pipeline going to look like in that case? So let's see that. So here, this infographic shows that the machine learning pipeline comprises of the three main pillars. The first is the build pillar, build stage. Next is the deployment stage, and the next one is the monitor stage. So what happens in the build stage is that you are not just ingesting the data set, you're doing the pre-processing, post-processing of the data set, but you're also training the model. And then you're testing your model, and then further packaging and registering the model after you have, realized, oh, this model is very good. And then further on, in order to release for the end users, you are packaging the model, and then you're, deploying in the production / in the dev environment. And then again, you will go in the monitor stage. So in the monitor stage, you're analyzing and governing your model and reiterating that stage, if there are some edge cases which are left, or you just want to improvise your model. So that's why you just circle back to the build stage. So this is a very high level of machine learning pipeline, and wait. So the question is, what if something goes wrong, especially in the build stage? So the next part of the talk will concentrate more about how we can deploy, again, build better machine learning models, especially in the build stage. Okay, but now let's understand the core problem of the talk, which is, through a couple of examples, that what is exactly the black box problem. Well, this is an example of the sampling bias, in which the face recognition algorithm is unfortunately not able to recognize the face of an innocent child, darker skin shade. And also the QR code on the right-hand side of my slide, you can scan it, and then you can get the access of the code, which has generated this, and also the presentation. The next example is the biased word embedding. So biased word embedding, it happens like, as you can see in this Cartesian, it's a vector space actually, which shows the affinity of the homemaker towards the women. What I meant by the affinity, the distance is very less between the homemaker and a woman as compared to homemaker and a man. So word embedding, in general is like the vector representation of the words or the text in a vector space. And the intuitive meaning is that the words which are closest in the vector space, they have a similar meaning. So does that imply homemaker and a woman, they have the similar meaning? Well, that's what word-to-vec algorithm shows, the representation here shows. So it's unfortunate because the word-to-vec algorithm was trained on a biased data set, which is the Google News data set. So, and also for the future reading, you can refer to a research paper that's titled as "A Man is to a Programmer, a Woman is to Homemaker," which talks about various biases and how we can mitigate, the ways to mitigate the bias. Okay, so this is a very shocking example. So the other day, I was just tinkering with the ChatGPT, and you can look very closely to it. So the prompt that I put in the ChatGPT is, the doctor yelled at the nurse because he was late. And then I asked the question, who was late? Just concentrate more on the pronouns here. The sentence that the doctor yelled at the nurse, he was late, right? So the he intuitively or logically represents nurse. But the pronoun, the answer given by the ChatGPT is, he refers back to the doctor. This implies that the doctor was the one who was late. Doesn't make logical sense to me at all. Okay. The next prompt which I put in is, the doctor apologized to the nurse for her late arrival to the emergency room. And then I asked a question, who was late? Who was late previously, right? But the prompt or the reply was, based on the sentence you provided, it seems that the doctor was the one who was late to the emergency room. And that's why he apologized to the nurse. Well, the genders have been changed in the ChatGPT. We are consuming the information given by the ChatGPT. Here I'm not talking about ChatGPT as a culprit, but the data set on which it is trained is not it's a biased data set. So once we are ingesting so much information from any of the generative AI models, we need to be very cautious about what we are consuming, the information that we are ingesting. Okay. Now, another example by the ChatGPT. Now, this shunned me so much. So the example says that the nurse apologized to the doctor. The prompt that I put in is, the nurse apologized to the doctor for his late arrival to the operation room. Now, the next question which I asked is, who was late? If you look closely in the answer, the ChatGPT said clearly and, again, I have no words to explain it. So the use of the pronouns in the sentence makes it unclear who was late to the operation room. That logically makes sense. I have given already the answer in the prompt. And then it reverses the gender, and then it also explicitly says that there is an error in the sentence construction. How can there be an error in the sentence construction? It's the prompt that I'm giving and also explicitly mentioning that the nurse apologized because the nurse is him or his. But And then it assumed by itself that the sentence, if the sentence was intended to mean that the nurse was apologizing to the doctor for her own arrival to the operation room, then the nurse was the one who was late. So how the change of pronouns, how the bias is so much inculcated. Well, the next example is it's a bias credit scoring mechanism. The certain section of the people, especially the people of the color, they really face a lot of discrimination, and therefore it leads to the unfair learning practices and potential discrimination. Okay, so after pondering, like a couple of examples and their biased and unfair outcome, now it's time for us to introspect. How did we get here? How can the models output such discriminatory decisions, So these are a bunch of the reasons I have listed here. Well, historically, the algorithms which are trained on the bias in the discriminatory data set could perpetuate the bias and amplify those decisions, which, especially towards the underrepresented sections of the society. And secondly, the lack of diversity which is within the data set, it could lead to some skewed results. As we know, that garbage in, garbage out. So if you're feeding in the biased data set, then of course you're going to get the biased results. And that uneven distribution of the class labels within the data set could lead to the inaccurate predictions. And the next one is the cognitive bias. So this gets actually introduced, when the individuals and the teams, they are not themselves aware of their own bias, whether they are training, whether they're deploying, or just building any kind of machine learning system. And the fourth one, which is something very important, is when you have the inadequate evaluation metrics, when they're not aligned with the objective that you're trying to achieve, that could lead to, haywire results. And the last is system bias, or systemic bias, you can say. So these are historical, social, and institutional bias that's sadly so much baked into our lives that it shows up during the machine learning training and, the design choices by default. For example, matching the white-collar jobs to the white people, or just the design problems that exclude certain section of the group of the users, especially those with the physical disabilities, from interacting with machine learning system. So, these are like a couple of reasons why bias, or, what all reasons could happen that lead to the unfair outcomes. We need to now understand which groups are affected the most from unfair decisions. So I'll just summarize this slide in a couple of sentences by stating that the people, those who are belonging to, one or more marginalized groups, they face like incredible discrimination because we don't have, I would say it's like positively distributed data set, because we have the lack of the fair and inadequate representation of them in the various demographic groups across the data set. Like we saw before, that the large language models associating all the nurses as female, which is so not true. Now this brings us to the third section of our talk, in which we'll discuss and explore the strategies to build the fair and unbiased models. But wait a minute, before we look for the strategies, we need to know what is exactly fairness in machine learning, right? So fairness in machine learning basically takes care of the two main brackets. The first is with regards to the protected attributes, or the sensitive attributes you can see, like the age and the gender. And the other one is with regards to the outcome. So when I say with the age and the gender is in the sense that, for example, the loan should be sanctioned to the people irrespective of their gender. Of course, the lending authorities are free to make their own rubric while they are, providing the loan sanctions. But eliminating just on the basis of the gender is not the correct lens of looking at things. And then the next one, fairness with regards to the outcome, is that the model should not harm or benefit any particular group or an individual. For example, Amazon's hiring algorithm penalized women applicants, those who have the same level of experience as well as the skills as their male counterparts. Though it was scraped off, but the underlying or the learning fact is that the model should not disadvantage any particular group based on the protected attributes. So these are a couple of algorithmic fairness techniques that we'll be looking at, and also I'll be giving a demo. So because we want to evaluate our models and how the model is giving a fair results. So the bunch of algorithms are, first is the demographic parity. Basically, it ensures that the model's predictions are similar across all the demographic groups. For example, if there is a loan prediction which is trained on unequal distribution of the different ethnic groups, then the demographic parity ensures that the model provides similar loan rates across all the ethnic groups. The next one is a statistical parity, which gives the difference in the probability of the positive outcomes between the privileged and the unprivileged group. By privileged group, I meant by you are free to make, if there is a male within the distribution of the data set and they have gender or on the basis of the age. So if there is a data set, then you are free to make a privileged group, or is it a male, or is it beyond the age of the 25 or something. And in the similar way, you can make your own privileged group within the data set given. The next one is the equal opportunity difference, which gives the difference in the true positive rate between the privileged and the unprivileged group. So what I meant by the true positive rate is, for example, there is a person who has a disease, and the model in itself is saying, oh yes, this person is having a disease. So it's basically positively classifying a positive class. It's not saying the person doesn't have a disease. So the next question is how to build fair and unbiased model and what strategies that we can follow. So these are the bunch of strategies that we can use to build the fair and unbiased model. First and foremost, that's a very thumb rule. You need to collect diverse and representative data set, because when your data set is representative of the entire population on which you are trying to build your model / your system, then it is going to eliminate 80% of the bias within it. And the next one is monitoring for the bias. So regularly monitoring your models for the bias and any kind of a discrimination using appropriate metrics can help to identify or correct any issues that can possibly arise. The next one is pre-processing and post-processing data set. So, you need to use data augmentation techniques, or maybe just use some feature selection, feature importance, and that's how different algorithms works through it. So using the data augmentation or any of the pre-processing data set algorithms or post-processing algorithms, you can actually balance the data set and just reduce the bias. The next one is regularization. So, having the regularization was not just only reducing the overfitting in your data set, but it also improves the generalization concept or generalization performance within your data set. And the algorithmic fairness technique is what I have explained in the previous slide. You can use such techniques because it will ensure that the model is treating all kind of groups equally. And the last one is explainability, which is the favorite of mine. Sorry. So building the models that are transparent and interpretable can help to identify and correct any kind of a bias which can exist within your model. So don't worry, I'll also give you the example and the demo of the explainability. That will cover in the next slides. But before that, I'll just explain a couple of strategies that we can use to build fair and unbiased model. Okay, so here, please let me know if you can see on the back. It's all good, right? Okay, awesome. So here, again, importing some of the libraries. Oh, the use case that we are trying to solve is given a German credit data set. It's publicly available. You want to do some loan classification, as in the people will get the loan or not with certain accuracy, yeah? So you have to define a model in that case. So again, firstly is importing all the libraries, and the language again is Python over here. And then you are loading the data set on which is publicly available on the UCL portal, and the certain feature names are, features are in the columns that the data has. It has the duration, status, and the previous credit history, what's the age and gender. And you can look into the description of all the attributes, because that's how the data set looks like. When you do the data.head, it will just give you the first 5 columns of the data set. Now, when I said the pre-processing the data set, because you have the categorical columns in the data set, of course, the system will not understand the categorical, so you need to convert it to the numeric, and you can use some one-hot encoding techniques. And then we are, just replacing. So here, the last column is the labels column. Again, it's a supervised, because we have already the label data set. So we are just replacing the class 1 and 2, and then we are just replacing it by 1 and 0. And 1 represents it's a good credit, and 0 is kind of a bad credit. And the next is we are defining, the features and what's the target going to be, and also the sensitive features we have defined here. By sensitive features is, because we want to do the classification, and at the end, I want to show how we can use some of the fairness metrics. So the gender and the age, these are the two sensitive attributes. Okay, when I say the data augmentation technique, so in the data augmentation technique, because the class imbalance is there, I'll show you why I have used a SMOT. So SMOT is one such technique that we can use for data augmentation. And SMOT, it's a statistical technique, basically to balance out the classes in your data set. And SMOT represents synthetic minority oversampling technique. Well, that's not my laptop, come on. Sure, so that's how it happens. It's good. Okay, now we're splitting the data set into the training and the testing. Because you have the entire data set, you want to split into the training so that the model will learn from it, and then you have to test on that, how the model has performed. So before applying the SMOT technique, you can see how, the representation of the class labels. So the 0 classes were something like 569, and 1 is 551. And after applying the SMOT technique, both are equally representative. Now I'm training the XGBoost model. You're free to use any kind of other tree-based classifier / whatever the classifiers that you feel like to perform the lone classification. And also you are free to use any kind of hyperparameters. Right, just for the demo purpose, I have, just feed it in, these are the normal parameters that I'm trying to work on with regards to my classifier. After passing in the parameters of the XGBoost model, now I have, it's the training of the model which is happening. And then the testing, which is kind of a normal thing. You just write the clf.predict and you just pass in your testing data set. And then you do the evaluation of the model. Definitely, the accuracy of the model is 84%. It's not hitting 98%. And then you're free to make the changes. So the core part is applying the fairness technique. Since I've explained, there are a bunch of techniques like demographic parity, equalized odds, and statistical. So here, I have used the equal opportunity difference. So in the equal opportunity, we knew that we need to calculate the true positive rates, right? So in the true positive rate, the function, it takes in the testing value, y test, and then it takes in the y prediction, and whatever the sensitive features that we defined, like the gender and the age, and then which particular group it belongs to. And then it calculates the true positive rate between the privileged versus, the difference in that, and then it gives you the equal opportunity difference of 0. So intuitively, when the equal opportunity difference is 0, then it's considered as a desirable, because it implies that your model is not creating any kind of, it's not favoring one group over the another. So that's one way. The next way is, that's a statistical parity. Okay, so in the statistical parity, again, we define our privileged group and the unprivileged group. Here I'm clubbing all the male, and after the age of the 18, and females after the age of 18, that's an unprivileged group, and then I'm just calculating the statistical parity difference. Since the difference is not that huge, so it implies that, the model is quite fair, right? It's not creating any kind of a bias in that case. So that's how we implement some of the fair algorithms. Next. Okay, yeah, so demo is also available on my GitHub. You're free to check it out. Now it's time for us to explore some strategies for building the trustworthy and accountable machine learning systems. But before that, have you ever wondered that why building trustworthy models is so important? Why we need to adopt trust in our systems? Yeah. So, users need to, either need to trust the machine learning system that it is providing kind of an accurate, reliable, and unbiased kind of a decisions. If the users will not trust it, then they are less likely to adopt it. And that could also lead to the poor decision making and also missed opportunities between the organizations and the users. Organizations, in a sense, there are so many organizations those are working on the cutting edge technology featuring in the machine learning, which is hot and new, and the users, which are the consumers. So if there is a missed opportunity, then there is going to be, imbalance in that case. And also, especially in the medical diagnosis or in the healthcare domains or / in the autonomous driving or, in automobile industry, the stakes are super high. And so the decisions made by the machine learning system will have the direct impact on the people's life. So it's also critical that the users trust the system to provide, that the system is going to provide the accurate and reliable recommendations. But trust is a two-way street, right? I can't trust onto you until you can't trust on me. So at the same time, to build the trust, machine learning system needs to be transparent. They need to be explainable and accountable, because users need to know how the system works and why it makes certain decisions. They also need to know who is responsible for the system and how they can be held responsible for its actions. So let's see some strategies to build the trustworthy models. Okay, so again, the thumb rule is having a diverse data set and high quality data set. It should be comprehensive, it should be representative and diverse at the same time, because we want to ensure it's a fair model, and we just want to prevent the bias as well. And the next part is using explainable and interpretable models. You just employ that machine learning models, they are going to be transparent and they need to be interpretable, because we want to avoid the black box problem as we saw before. And next one is we need to evaluate our models and just monitor them continuously, just to identify if there are any issues and also to ensure accountability. So the next one is involving the multiple stakeholders in the development process. So it's a very critical, because there could be stakeholders, those are belonging from different genres, or maybe like from the different domains altogether. Maybe the experts in the ethics, experts in the privacy, or experts in the security. When you're developing any kind of machine learning system, it's better to take their opinion about it, so that the system meets their expectations, needs of all the stakeholders. The last one is you need to regularly update and improvise your machine learning model, because you want your models to remain current, accurate, and reliable at the same time. And the next one is you just need to prevent that the systems are not becoming outdated and biased at the same time. So we will see the explainability implementation in a couple of seconds in the next coming slides. But wait, before that, the theory is more important, right? So I can't, if I don't have understood the theory behind it, how can I implement it? So, explainability is one of the very trickiest things, because we need to manage the ramifications of machine learning models. So, in explainability, what happens basically, it refers to the ability to understand and interpret how a machine learning model arrives at its decisions. An explainable model, or an interpretable model, in other words, provides insights into the underlying factors that can influence its decisions / the predictions. Because humans need to comprehend why it is making those decisions and needs to trust its output. And this is very much important, especially in the sensitive applications when we are building, be it in healthcare domain, be it automobile, or the criminal justice. You definitely don't want an innocent to get, death sentence if your model is just giving the random or haywire outcomes. So that's where accountability and trustworthy, and transparency are crucial. Okay, so let me give you a quick demo. So in the previous, again, I'm using the SHAP and the LIME. These are the two libraries that we can definitely use for getting the explanations of our model. I've used the SHAP and LIME in my previous example, because in the previous example, we were doing the loan classification on the German credit data set. Here, after using the LIME and the SHAP, you can see the summary plot. So basically, it represents that which features play an important role in making the predictions of your model. And of course, the features which are on a higher, higher as in on the red state, then of course those features play a crucial role. The next one is the LIME. So LIME is one other important aspect. It's used for the explainability. LIME actually goes much more deeper. For every particular instance, it is going to give which features play a which role. How much contribution are they providing in giving you the output? I'll actually give one very intuitive example of using any of these LIME and SHAP. Okay, so let's see. That's a very basic example, actually. And I hope that's intuitive as well. Okay, importing the libraries, important step. Now the sample training data. You just look in the sample training data at the moment. It's very small. It has, like a couple of sentences actually. And then it has the labels as well. So one of the sentences in the sample training data is, I love the beaches here at Malaga. So this is my first time, of course, so I'm going to go to the beaches. So yeah, this movie is terrible. I know my time is up, but I'm going to finish all the slides with the demo. So this movie is terrible. So that's, again, one of the sentences in your training data set, and it's labeled as 0. So 1 implies it's a positive sentiment, and the 0 implies it's a negative sentiment. Just to give an intuitive example, what's a sentiment classification is, for example, I would say that I am super excited to be presenting in front of all of you, and especially thankful to the organizers for giving me an opportunity to share this platform with so many experienced speakers whom I can't even imagine in my life. So that's a positive sentiment, right? And the negative sentiment could be, I don't like the pineapple on a pizza. Who eats that? So that's a negative sentiment, right? I mean, I know my brother eats it, but I really hate it. So, okay, now we are training the logistic regression classifier. You are free to use any other classifiers, which will give the better accuracy, but for the time being, we are just using the logistic regression classifier on the data set. And before that, we have also vectorized the data. So see, you need to always, whenever you're working on the NLP statements, when you're dealing with the textual data set, you need to vectorize it, because the system will not understand the textual format of the data. You need to do it, in the numeric format it needs to do. So we have vectorized the data set using the logistic regression classifier. Now, after training the data, training the model, now it's time for us to test it out. So the text which I have given to test it out, and I'm using the LIME classifier, actually LIME explanation, just to see how it is performing. So the test to explain, it's a sentence which I'm just testing on my model which has been trained. And it says, so the sentence is so exciting to be presented at the Gion Beach conference in Malaga. That's a positive sentiment, right? And it has also highlighted the words which are giving those predictions, why it is positive, and at the same time, with what probability. So the probability you can see over here, it's a positive probability with 0.68. And at the same time, these are the words which are contributing towards the positive. Right? It's positive sentiment. So the highlighted words are the ones which are contributing. So now this is a very intuitive example, because we know why the model is making such kind of a prediction. So that's why explainability is a very crucial aspect. And also there is a slight difference between explainability and interpretability. I'll give one intuitive example for that as well. Suppose you have a car, and we know that a car needs a fuel to move. Without that, it won't. Of course, there are electric cars, but I'm not a big fan of Elon Musk electric cars. Sorry, the people, those are the Elon Musk fans out here in the audience. So a car needs a fuel to move, and it is that fuel which causes the engines to move, right? So that's an interpretability. But understanding how and why the engine consumes and uses fuel, it's an explainability. So you need to draw a comparison. I want to check whether my model is giving better results, and if it is giving, can I have the explainability plugged in my model as well? Just to get an intuitive idea. Okay. Now it's time for us to see. Okay. Who is responsible for considering the ramifications of the machine learning system? Is that I'm going to bug Elon Musk because his Tesla is not giving the right direction? Well, I don't know. So there are multiple stakeholders which are involved in the development, building, and the deployment of the machine learning system, be it the developers or the data scientists. So every stakeholder is responsible for their own actions. Especially for the developers / the data science, they need to ensure that the data that they're working on, it's not a biased data set, right? And that you can easily check through hypothesis testing / getting the insights from your data set. And the business leaders / the visionaries, and then regulatory bodies and organizations. And the last one is the consumers and end users. So definitely we can't pinpoint one particular stakeholder. Oh, you are the one who is responsible, who is the evil behind all these things. Well, so the underlying fact is, it's indispensable for every stakeholder that they take their action or whatever the responsibility they're sharing with a plan and a caution. So that's the key takeaways from my talk. Bunch of key takeaways, I would feel like it's, when you're building any kind of a fair, accountable, or trustworthy model, it's very important that it should be for the wider accessibility. You want to build an inclusive environment, and that's what the aim behind building all these large language models is. You want the technology to be much more inclusive. So the models also need to be explainable, transparent, and interpretable at the same time, so that we can mitigate any kind of a bias and deeply, think through the solutions. Last and most important is you need to monitor and evaluate our models to ensure accountability as well. And these are a bunch of resources. I would highly give a shout out of the course, which is Introduction to Deep Learning at MIT. Please check it out. And hope you have enjoyed the talk. And yeah, that's all I have for you today. Thank you very much for being a warm and lovely audience.